Okay, good day, scholars. This is what redox reactions. We're going to talk about oxidation reduction reaction. Now, when we hear redox, here means red is for reduction, ox means for oxidation. So both of them are complementary. What do I mean complementary? They're like brothers and sister, like they're like two brothers, or let's say husband and wife. Like they are complementary. They need each other. You cannot find a reaction where it's only oxidation that is going to happen. No, or it's only reduction that is going to happen. Both of them need each other. They must happen in that reaction. Both of them. Do you understand? Is it that they are there or they are not there? Do you understand? One cannot be there. Two of them has to be there. So now, reduction and oxidation were defined in many terms. In like let me say about three or before. Number one is in terms of oxidation and removal of oxygen. Number two, in terms of addition and removal of hydrogen. Number three, in terms of electron loss and gain. This is the modern way. Do you understand? So now let's talk in terms of addition and removal of oxygen. The first one, and we have to be very, very fast. I don't want the video to be lengthy. Number one, so let's define oxidation. Oxidation oh, oxidation can be defined as the addition of oxygen to a substance. So any substance that oxygen is added to, that substance is said to be oxidized. That substance is said to have undergone oxidation because what oxygen was added. Just get that concept. Addition of oxygen. So now let's say oxygen was added to Mr. Val, me here. It means that Mr. Val has been oxidized. Get that? So let's say this is oxygen and it was not added to me. Like this now, I'm oxidized. If you remove it, I'm reduced because of what? This oxygen has been removed from me. That's what we call reduction. So reduction is the removal of oxygen from a substance. So now let's talk about oxidizing and reducing agents. Agents. Remember, if you are, I don't know, if you have gone to look for a house before, sometimes it's not, most times it's not you that will look for the house or you want to buy land. It's what? It's an agent that will look for the house for you, right? So in these chemical reactions, we have this redox reaction, we have agents that do this work. There's an agent that will make sure that this oxygen was added to me. There was also an agent that made sure that I gave out this oxygen in terms of reduction. There was an agent that made sure that this oxygen came to me in terms of uh, oxidation, so I will be oxidized. So now let me give you an instance now. Oxidizing agents, I'll be very oxidizing agents, which is what? OA, is termed oxygen donor. It is this oxidizing agent that will donate oxygen to the reducing agent. No, let me not even, so that you guys will not get confused because you know this thing is confusing, but relax. Oxidizing agent is oxygen donor. When something donates, these things, these two were added together and it donate, this red one donated this. This red one donated this. As he donated it, what does it mean? It means that oxygen, this thing is oxygen. It has been removed from this red one. It, ha- it has been removed from this red one. And removal of oxygen, what do we call it? Reduction. So in the process, that oxidizing agent has said to have undergone reduction, or I say it is reduced. Somebody say power. Then let's say uh, reducing agent RA. This is what we call the oxygen acceptor. Now this brother now dey accept oxygen. Make I use pidgin. Now this one, this RA, na him go accept the oxygen. Now let's give an instance. This is oxidizing agent. This red one is oxidizing agent. This blue one is reducing agent. Now look at what will happen. Okay, let me drop this one. This red one is oxidizing agent and it has oxygen with it. This blue one is reducing agent. Now look at what will happen. Let's say this red one now will now give oxygen to this blue one. As I was giving this blue one oxygen, this blue one is reducing agent. In that process, this blue one now has been oxidized. It has undergone oxidation because of what? A substance. This blue one is a substance. Oxygen was added to it. It has undergone oxidation. It's said to have been oxidized. Then this red one that gave out this oxygen has been reduced. You see, it has been reduced. If you want to put it in another way, you have to talk like a science student, not like a market woman. If you want to put it in another way, you will say that the reducing agent, this blue one, reduced this red one, which is oxidizing agent. How did it reduce it? It removed oxygen from it. That's why it reduced it. That's why it's called the reducing agent. Now, let me tell you something. The reducing agent itself is not reduced, it is oxidized. But what does it do? Why is it called the reducing agent? Because it is the one that reduces the other, the fellow brother. You understand? It is this one that reduces this one. How did it reduce it? By removing oxygen from it and adding it to its own self. Let's take it in another way. If this is okay, don't worry. I'll use a reaction to give it, but I believe that this one you must have understood it. So this one will be oxidized in the process. I call it oxidation. Anyone? Now let me give an instance. See this reaction. Now, according to you now, these are the two reactants. Which one now, before I answer it, which of these is the oxidizing agent and which one is the reducing agent? Observe the reaction. Pause the video and check it. Let me start again. Let me start. Now, see, which one was oxygen added to? Carbon, right? This is carbon. So this is the reducing agent. Then this is the oxidizing agent. You see that I'm explaining with this pen? Now look something. Carbon reacted with zinc oxide to form carbon 4 oxide and zinc metal. Observe something. Zinc was associated with oxygen here, but here it's not standing alone. What does it mean? It means that zinc gave out oxygen, it donated oxygen to carbon. So zinc is the oxidizing agent here. This zinc oxide is the oxidizing agent. It gave out zinc here specifically is oxidizing agent. It donated this oxygen. As it donated it, in the process, it became reduced to zinc. Because oxygen was removed. Then look at this one, carbon. Carbon accepted oxygen and became what? Oxidized. I call it oxidation. Do you get? Carbon accepted oxygen. So we can now put it this way, that the reducing agent, which is carbon, reduces this oxidizing agent. Or we put it this way, the oxidizing agent, which is it, oxidizes the reducing agent. Have you seen both of them are brothers? The reducing agent will reduce the oxidizing agent. The oxidizing agent will oxidize the reducing agent. You know, in normal, let's say in normal sense, it will be like, it's not the oxidizing agent that will be oxidized. No, have this at the back of your mind now. The oxidizing agent is the one that will be reduced, while the reducing agent is the one that will be oxidized. It will undergo oxidation. So see this simple this thing now. That's just it. So now let's talk about in terms of uh, addition and removal of hydrogen. Let's define oxidation in that way. I'm not going to claim much. So we want to define oxidation in oxidation and reduction in terms of addition and removal of hydrogen. We are done with oxygen. Now, oxidation can be defined as the removal of hydrogen from a substance. So whenever hydrogen is removed from a substance, just know that it's oxidation. Then remember I told you oxidation and reduction has to be opposite of each other. So if oxidation is removal of hydrogen, that means reduction is definitely going to be addition of hydrogen. Reduction is the addition of hydrogen to a substance. Hydrogen to a substance. So I believe you must have written this down. It's simple. The oxidizing agent is going to be the one that is going to be reduced. You understand? Oxidizing agent is going to be the one that will be reduced, or you say will undergo reduction. That means oxidizing agent will be the hydrogen acceptor, while reducing agents will be the hydrogen donor, because it's the one that is removing the oxygen, removing the hydrogen. Let me give an instance with a reaction. Let's say what did you observe? This is hydrogen sulfide reacting with copper chloride, chlorine gas to give hydrogen chloride, and sulfur metal sulfur non-metal element is given off, is formed, is deposited. This is a yellow deposit of sulfur. Now check something. Hydrogen sulfide, this is going to be the this is going to be the reducing agent. This is going to be the oxidizing agent. Just know that group 7 elements are just oxidizing agent, because this is a group 7 element. Now look at what happened here. Hydrogen was added to chlorine to give what? Hydrogen chloride. So chlorine was reduced. Why was it reduced? Because hydrogen was added to it. This was oxidized. Why was it oxidized? Because of what? Hydrogen was removed from it. Hydrogen was removed from sulfur. That's why it was oxidized. Hydrogen was added to this oxidizing agent. That's why it was reduced. Oxidizing agents will always be reduced, while reducing agents will always be oxidized. So that's it. Now let's go to in terms of electron gain and electron transfer. We have to be very, very fast so that the video will not be lengthy. I will not be writing define. You understand? So oxidation is simply the loss of electron. Now, this is the modern way of defining oxidation and reduction. While reduction, if this is loss of electron, remember it's going to be the opposite. Reduction is going to be what? Gain of electron. So the oxidizing agent OA, which one undergoes reduction? Oxidizing agents, but so you call the oxidizing agent electron acceptor. Why the reducing agent, you call it what? Electron donor, because now they give in the process it will become oxidized. Electron donor. Let me give an instance. You remember in that first this thing we did? Let me use this as an example. Now look at something. Reducing agent, oxidizing agent. Now the oxidation number of carbon here is what? 0. We are still going to talk about oxidation number and oxidation state. Why that of zinc here is what? +2. Oxygen is always -2. Now, one thing you should know that any element that is standing on its own will always have an oxidation number of what? 0. So oxidation state of zinc here is what? 0. Why here is +2? Because it is combined, +2. Now observe something. Carbon will be oxidized to carbon dioxide because it loses 4 electrons. It loses 4 electrons. You understand? It loses 4 electrons. Why zinc accepted 2 electrons to become zinc metal? Now let me give another instance again. Which one will I use and give an instance? A better one safe. Observe this. Again. Observe this. It's balanced. 2 times 2 4 plus 2 6. 2 times 3 6. Okay, it's balanced. Now this is simply talking about the oxidation of what? Iron 2 chloride. This is iron 2 chloride. How do you know? Because the oxidation state of iron here is 2. Is +2. Let's find out. How do we know? FeCl2 equals to 0. Equate it to 0. Chlorine is always -1. So we check Fe plus -1 to equals to 0. Fe 2 times -1 minus 2 equals to 0. Fe equals to 0 plus 2, because collecting like terms. Fe equals to +2. So the oxidation state of iron here is +2. Chlorine is standing alone here is 0. And I told you that chlorine is oxidizing agent. This is a reducing agent. Now check something. Now the product here is what? Iron 3 chloride. How do we know it's iron 3 chloride? Let's look for the oxidation state of iron here. Equate it to 0. Fe plus 3 minus 1 close bracket equals to 0. Fe plus 3 minus 1 times -1 is what? -3 equals to 0. Fe equals to 0. Collect like terms plus 3. Fe equals to +3. So oxidation is simply increase in oxidation number. The oxidation number of iron increased from +2 to +3 here. So this is what we call what? Increase. This is what we call oxidation. So this simply, if you want to transcribe it, it's called loss of electron. Iron 2 here loses 1 electron to become iron 3. I will explain further. You know, just be following us in the course of this class so you will not get lost. Now let me talk about oxidation number. Oxidation number is simply the number, is the electrical charge of an element. Molecule or an ion. Do you understand? So the oxidation state of, what's it called? The oxidation number of this is what? +1. This is what? +1. Mg 2 plus equals to +2. Calcium 2 plus equals to +2. Do you understand? Now let me tell you the rules of determining oxidation number of various elements, compounds. Let me tell you the rules. Number one rule is any element that is standing alone has an oxidation state of 0. Any element that is standing alone, so far it's standing alone, the oxidation number is what? 0, or you call it the oxidation state. The oxidation number expresses the oxidation state. So don't be confusing and mention oxidation number or oxidation state. Both of them are the same. It's just that oxidation number is what expresses the oxidation state. So any element that is standing alone has an oxidation state of 0. Just that it's often omitted. Let's say you see calcium that is standing, you see calcium like this. The oxidation state is 0. It's like this, but it's often not written. So that's why you just put it Ca, Mg, like you just like that. That's why chlorine, any element just be going. So far the element is not combined with another element, it's in a free state. Just know that the oxidation state is what? 0. If it is two elements that are combined, then the oxidation state is the sum of the two of them. Let's say for example we have sodium chloride. How do we get the oxidation? The sum of this and this will make up the oxidation state. For example now, Na plus this equals to what? 0. Because of what? Na is what? +1. This is what? -1 equals to 0. So you equate NaCl equals to what? 0. Let's say in terms of radicals, we have OH. How do we know the oxidation rate of this radical? See, it's simple actually. You equate it. Oxygen is what? -2 plus hydrogen is what? +1. Plus you equate it. We want to look for the oxidation of this radical. +2 minus 1, -2 plus 1 is what? -1. So that's why OH is always written like this, OH minus. Do you understand? So that's it. Now let me show you number line, how you can be used to represent your the oxidation and reduction stuff. Let's say here is 0, -1, -2, -3. It can be going 0, +1, +2, +3. Now Every element that is standing on its free state is what? In neutral state, 0. Now, let's say it loses electron. It's going to this side, loss of electron. Now, in normal sense, loss should be going to negative side. But in this chemistry now, loss is going to positive side, while gain is going to what? Negative side. So here is what? Gain of electrons. So let's say Mr. Val gained 2 electrons. Now, Mr. Val, I'm standing alone in my neutral state, 0, and I get 2 electrons. Look at what will happen. I'll move from here. Instead of going here because it's gained, no, you come here and you stop here. So now Mr. Val now have an oxidation state of what? -2. Let's say Mr. Val is in -2 and Mr. Val loses 2 electrons. Look at what you do. You now move from this -2 to 0. That's why if you observe, that time hydrogen sulfide was combined. Sulfur was combined with hydrogen like this. It now deposited sulfur. And you know that sulfur is standing alone is what? Has an oxidation of 0. But here now, what's the oxidation state? How do we know? This is 2 plus x equals to 0, x equals to 0 minus 2, x equals to -2. Sulfide here has -2 minus here. How did it move from 2 minus to 0? Because of what? It lose 2 electrons. So it's here, it's moved from here to here, moved from here to here, and stopped at 0. So this is what we call loss of electron. So we can now say this sulfide here loses electron to become sulfur atom. If you want to reverse it again and put it this way, it will be sulfur atom will now be reduced to sulfide, which is what? -2. It will gain 2 electrons to become this. But if it's going back, it's going to be oxidation. That's why I put oxidation like this. So oxidation must also start from here and go here. It can start from anywhere. It can move from here to here. Do you understand? So always use this number line to represent it. So we can start solving some stuffs so that you will be understanding more and more. We have what we call oxidation half equation and reduction half equation. Once there's an increase in oxidation number, I don't want to write this one down, but just note it. You can write it yourself. Once there's an increase in oxidation number, once there's an increase in oxidation number, once there's an increase in oxidation number, the this thing, the substance is said to be oxidized. But once there's a decrease, it's said to be reduced. Now check what did you observe from here? From -2 to 0, is it an increase or decrease? It's an increase now from -2 to 0. Sure, you know 0 is bigger than -2. It's better yes, you don't have money, but you are not owing anybody. But -2, you are owing somebody. You will not have peace of mind. Do you understand? So that's why 0 is. So somebody that doesn't have money but is not owing anybody is better than somebody that doesn't have money and is owing someone 2 naira. Do you understand? So from now let me show you something. Let me do the half equation for this. So this is what we call oxidation half equation. What does it mean? It means that this sulfide ion loses 2 electrons. Sulfide ion loses 2 electrons. So this is how to represent it. It loses 2 electrons to become oxidized to what? Sulfur atom. It will be deposited as sulfur atom. Now let's look at this one. This ion 2 ion, it's now moved to ion 3 ion because what? It gained one electron. Ion 2 ion, let's use the number line. Ion 2 ion is here. It's now lost one electron. It's now moved from here to here. That's why it's now plus 3. But let's say it's in ion 2 ion and it's gained 2 electrons. Do you know where it will go? It will go back. Gained is reduction. It will come back like this. It will move from here and stop here. Let me give an instance. Let me show you. This is what we call reduction half equation. Reduction half equation. Ion 2, where ion 2 ion gains 2 electrons to become reduced to ion metal. Ion 2 ion, why this one is ion 2 ion loses 1 electron to become what? Ion 3 ion. This one is ion 2 ion gain 2 electrons to become ion metal. And when I told you that any element standing on its own has oxidation state of what? 0. So you see now, ion 2 ion here is here and it's gained 2 electrons. It moved from here and stopped here, which is what? Neutral. So do you get? That's it. Let me give also another instance with that zinc chemical that I did that time. That zinc oxide stuff. We want to, you know what we are doing is the half equation. So we want to remove this oxygen. First, before we remove the oxygen, let's find the oxidation state of zinc in this zinc oxide. ZNO equals to what? You equate it to 0. Oxidation of oxygen is always -2. -2 equals to 0. Zn equals to 0 plus 2. Zn equals to what? Plus 2. So doing this thing is going to be what? Zn2 plus Zn. So we can now say zinc gains 2 electrons to become what? Zinc metal, which is what? 0. Zinc was here plus 2. It now gained 2 electrons. It now came here. It's now 0. Understand? So that's it.